Today we're going to do 12.3. We're starting a new chapter, chapter 12, which is all on rational expressions. And today we're going to do simplifying rational expressions. So to remember what a rational number is, think back to the beginning of the year where we talked about the different sets of numbers. Rational numbers are numbers that can be written as a fraction. So rational expressions are just polynomial fractions that have a polynomial in the numerator on the top and a polynomial on the denominator, which is the bottom of the fraction. So, for example, if we can say that a rational expression is represented by p of x over q of x. So these are just functions. So it's basically saying we have a function on the top. So for example, we could say we had x squared minus 3x minus 4 on top. We have a quadratic. And maybe we have x minus 5, a linear, on the bottom. This would be a rational expression. So it's just a fraction that has variables in it. So just like in fractions, we always reduce our fraction. When we leave a fraction as an answer, we always reduce it. We have to simplify or reduce rational expressions, and that's what we're going to do today. We're going to reduce these or simplify them. So the steps for doing that, the first thing you want to do is factor. You want to factor the polynomials on top and bottom, and then cancel like terms. So let's kind of look over here and think about just with real numbers. If I gave you 8 over 12, you would, if I asked you to factor the top and bottom, you would say 8 is really 4 times 2. And you could say on the bottom that 12 is really 4 times 3. So if I asked you to simplify or reduce this fraction, you would cancel out the 4's and you would be left with the final answer of 2 over 3. So you're really canceling out a common factor. Our common factor here is 4. So we're really looking at the same thing here. If I look at 5m squared over 15m, this is really 5 times m all over 15m. I have a common factor of m that can be canceled out. And if I think of 15, that's really 5 times 3. So I can cancel out a 5. So if I look at this, I'm going to be canceling out a 5. So really what cancels out here? My m cancels, my 5 cancels, and leaves me with the 3 down here. So we can really kind of get rid of this. 5 goes into 15 3 times. So what do I have left over? I have left over an m and a 3. So my final answer here is going to be m divided by 3. Let's look at example 1b. I'm going to factor. My first thing is to factor the top and the bottom. So when I factor out the top, I can see that I can factor out a 6p. I factor out a 6p, that's going to leave me with p squared plus 2. On the bottom, p squared plus 2 can't be factored. There's no common factor there that I can factor out. It's not a difference of squares. So I kind of think about this on the bottom as its own factor. I like to put things in parentheses because whatever's in parentheses I can cancel. So one thing that I can't do, I have to factor first. If you notice back up here, I had no addition or subtraction. I could only cancel things that are multiplied together. Same thing here. I can't go through and cancel. I can't cancel these p's. I can't cancel the 2 here. I can only cross out things that are multiplied together. So what things can I cancel out here? I can cancel out the p squared plus 2 and the p squared plus 2. Those are factors, so I can cancel those out, and I'm left with 6p. The biggest mistake or the most common mistake is people trying to cancel things that are added and subtracted. Has to be things that are multiplied that can be canceled out. If I look at this next one, 3n can't be factored. N minus 2 can't be factored. So when I like I said, I like to put things in parentheses. That means there's nothing that can cancel. I cannot do this. A lot of people want to take the n's and they want to cancel them. I can't do that because there is a subtraction sign here. So this is completely factored. My final answer is this. This is considered simplified. Let's go on to example 2. Now we have more quadratics going on that we're going to factor. So we're going to factor everything first and then cancel out common denominators. So we have to remember how to factor quadratics with the leading coefficient of 1. We ask ourselves what multiplies to 16, adds to negative 6. So this is thinking back to here. What multiplies to 16, negative 16, adds to negative 6. That's going to be a negative 8 and a positive 2. So I can factor the top. It's going to be x minus 8, x plus 2. On the bottom, we want to say what multiplies to 6 and adds to 5. Same thing here. What multiplies to 6 adds to 5. That's going to be 3 and 2, a positive 3 and a positive 2. 3 times 2 gives me 6. 3 plus 2 gives me 5. So I get x plus 3, x plus 2. So now I have to check. I factored the top. I factored the bottom. Do I have any common factors? X plus 2 on the top and x plus 2 on the bottom are my common factors. This is what I'll be able to cancel out. Whatever I have left over is my reduced fraction, so x minus 8 over x plus 3 is my simplified fraction. On the last example for 2, doing the same thing, it's just seeing different kind of factoring. If you can recall from our factoring chapter, this is difference of perfect squares. So I can factor this. So when we have difference of perfect squares, both terms have to be perfect squares, and I need to have subtraction in the middle. So this is going to be x minus 5, x plus 5. Those are the easiest to factor. On the bottom here, we want to say what multiplies to 25, adds to 10. I'm going to do my little x here, so 25 and 10. 5 times 5 gives me 25, and positive 5 plus positive 5 gives me 10. So I'm going to have an x plus 5, x plus 5. I have a common factor here of x plus 5. So that will cancel out. I don't have any other common factors, so I've now fully reduced my rational expression. It's going to be x minus 5 over x plus 5. And we just have 2 more here. On the last 2, they're the same pretty much. I just wanted to look at A. A has something a little bit different in it. So first thing that we want to do is factor. I noticed that I can take a 2 out of the top, so I'm going to get 3 minus x. On the bottom, I notice I can factor out a 2. So I get x squared minus 2x minus 3. I can continue to factor the bottom. The bottom will continue to factor, and that's going to give me x minus 3, x plus 1. What multiplies to 3 adds to negative 2. So that would be negative 3 and 1. So now I notice something. What I want you to pay attention to is see how these are almost the same. So these are almost the same factor. But their signs are different. So what you need to do is factor out a -1. So let's look at what that looks like then. If I factor a -1 out of the top, I'm going to get 2 times a -1 times x minus 3 all over 2 times x minus 3. So when I factor out a -1, that flips that around. So now we can see these are exactly the same. I can cancel these now. Oh, I forgot my x plus 1 on the bottom. We can also cancel the 2's. So that leaves me with a final answer of -1 over x plus 1. So that one's a little bit different just because you have to factor out that -1. And you do that when you see two binomials, which is an expression with two terms, two binomials that are close to each other but not exactly the same. We can go a little quicker on this one. We're going to factor this, so I can factor out a 3 on the top. That's going to leave me at x minus 11. On the bottom, I have difference of squares again. And so 121 is a perfect square. 11 times 11 gives me 121. So I'm going to have x minus 11, x plus 11. I fully factored it. I'm going to look for common factors that I can cross out. I can cross out x minus 11. That'll cancel. And this leaves me with 3 over x plus 11 as my final answer.